Well, hello everyone, and welcome to our webinar on SMB Stream, fast, secure, VPN-less access to remote SMB shares. In this live demo, we'll show you how the new Enterprise File Fabric feature, SMB Stream, makes file shares from external sites available to remote workers, no client-server installation or network changes. As a reminder, you can find more information on SMB Stream in the handouts section of this presentation. There you have a solution brief, and also the session will be recorded, uploaded to our YouTube channel, and you will receive an email with a link to the video as well. Any questions you may have throughout the presentation, as usual, you can leave those on the question box, and then the team will happily answer those. So now over to our presenters. Doug, Director of Product Solutions, and Eric, Director of Sales Engineering at SME. Hi, guys.
Hey, how's it going?
Hey, very good. Hi, Mariano.
Hey.
All right. So, Eric, why don't you kick it off?
Yeah, absolutely. Thanks for your time today, everybody. So what we want to talk about is problems that customers face with remote office collaboration. So in our field, we often talk with a wide range of different customers, and what we see is that remote collaboration, remote workers, is an ever-evolving landscape for our customers, for our enterprises. In the past, you could imagine a scenario where a customer would have a group in New York City and a group in LA and a group in Austin, and the projects they were working on would be sort of self-contained, right? The New York City group would work on New York City projects. Maybe occasionally they would communicate with their team over in LA, but really everything was sort of co-located with the people that was working on those projects. What we've seen is now that model is starting to break down, and we often see customers wanting to collaborate across those office locations on that same data. They've turned to things where, for example, both the LA and the New York team are working on the same project at the same time, or maybe even, the Chicago team has some free cycles, so they're going to take over a project that the Austin team started on. When they take a look at that, they can move to one of two options to try to solve those problems. And of course, those lead to additional problems that need to be addressed. Right? So the first is cloud services, all the sort of sharing and collaboration cloud services that they may want to leverage to do that collaboration across the offices. Obviously, the Enterprise File Fabric was designed to fill that gap. But we also saw that while that does solve one need, we saw customers also looking to address that cross-office collaboration in another way, right? And that's by using things like VPN or WAN accelerators or network technologies to try to offer up that SMB share or that NAS share directly to the people in the other offices. And as they started to do that, right, they ran into problems, multiple problems from a technology perspective to just try to get that SMB share data across a VPN or a WAN accelerator off to another location, right? So just making sure we're all talking the same language, we're all on the same page, right? When you think about then taking that data and moving it across a VPN, right? A VPN does a lot of things well, but at the end of the day, it's just encapsulating data to transfer that those connections across from one to the other. So we're going to encapsulate that SMB traffic in a VPN tunnel to send it across. What customers often try to do is say, well, if it's slow, let's just get a bigger pipe. Let's get more a bigger VPN device or a bigger internet pipe between our locations to try to speed that up. And I'm sure all of you, like me, buy a lot of things from Amazon, right? And what we see is quite often we'll get a big box and we'll start to open up that big box and see the same small thing in that big box as we would have got in the smaller box. And we start to think, well, why was it shipped that way? Well, you can think of a larger VPN box just like that larger Amazon box. It's not going to speed it up. You still have that encapsulated data, transferring that across. The other issue that customers run into, especially as they start to look at those remote offices and the technology expertise at those remote offices, as well as the ever-evolving security landscape at those offices, VPNs can be a bit troublesome to set up. whether that be firewall rules or routing configurations that are required in order to get that up and running, it tends to be complex to get up and running. And then finally, especially when we start to layer on top, hey, let's try to speed up this traffic by things like WAN acceleration. Well, typically they're going to leverage things like compression and deduplication to try to speed up that traffic. Well, a VPN, as we know, is all encrypted. So that data natively has probably been encrypted already as part of the, compressed already as part of the encryption, and doesn't really deduplicate well. So all of those WAN acceleration technologies don't really help with that VPN. In addition, right, the underlying protocol that SMB uses also has limitations and issues using at scale across those remote offices. So, TCP is the protocol of choice for SMB, and that really is designed and works great for a lot of use cases, but especially as you start to work across large distances and across the SMB protocol as well, that runs into some problems, right? So again, not to get too overly technical, but within the TCP protocol, you have this idea of a window, right? And this data is set in windows. And what needs to happen is on the other side, once you send that data all the way back through that long pipe, the other side needs to see that entire data within the window. And if there's any sort of latency issues, it will need to basically go and say, oh, I've lost one of those windows. You need to retransmit the entire thing. And that really also comes into, as we see in the next bullet, TCP is designed as a stateful protocol. When you get packets delivered out of order, it's going to wait and try to see, okay, do I have that packet that I missed delivered out of order, and then try to reassemble it when it arrives. Or if it just takes too long or is lost, it has to retransmit that entire thing all over again. And then on top of that, right, as we think of the internet at large, the whole idea of the distributed scaled out internet is that you may not have the same path for all of your session that is sent across, and you may have dropped packets within there, right? So what you end up seeing is for those long distances, the protocol of TCP has issues, particularly as it relates to the SMB traffic, which cause, as mentioned, issues for that data access across that long pipe.
Hey, Eric, we have one question already, and somebody says, TCP doesn't seem to be my problem. It works downloading from my website, but it's slow with SMB, and they wrote 10 megabit, 1 megabit. So I assume that means that they're getting like 10 megabit pulling. I guess their question is, going over the VPN with TCP, they're getting a different performance between using like a website, their corporate website, I guess, or maybe that SharePoint or something, and SMB. I think you're going to address this a little bit more, but if you wanted to say anything about it.
Yeah, no, absolutely. And I think that feeds pretty well into the next slide, actually, right? So we can think of the underlying differences, right? So TCP, as mentioned, potentially has issues across large latency environments, but often the underlying protocol that it's using can often make up for that or account for that, right? The problem is that SMB at its core is designed to operate in a low latency environment, right? So potentially, when you're encapsulating that data over a VPN, sending it across the internet, taking that TCP traffic, encapsulating that across, you still run into issues because of the underlying nature of the SMB protocol. So, the first thing is just, it's a very chatty protocol. There's a lot of back and forth between the client and the server in order to do all of the different traffic that is required to download a file or even browse through and open a file. Again, designed for this idea of users co-located with the data. So now, yes, we can use a VPN. Yes, we can try to encapsulate that data. But at the end of the day, the protocol itself still is designed and operate in a local latency type environments. The second issue that you could potentially run into is you have to be careful about how you set up your packets, both from the VPN perspective as well as the SMB perspective, right? You can imagine within a VPN, you're taking this traffic that is being generated by SMB, breaking it up into small chunks and sending that across from the VPN side. And often you can run into issues depending on how things are set up, where you've got a a packet within your VPN doesn't neatly fit into slices of the packets that are coming across from SMB. There are ways that SMB tries to alleviate some of that from a multi-channel perspective, right? So you can have multiple streams going on at once. But that also has some complexity with it as well. It is first off newer from a protocol perspective, and second off, it's a little more complex to set up, and many devices or many customers just opt to not do multi-channel as part of their setup. And really just circling back to, as we described before, well, one of the things that people often try to do is say, okay, let's put a WAN acceleration technology in here in order to try to speed that up as well, right? And again, just like with the VPN side, we run into issues with the protocol level as well. So if we look at the SMB3 protocol, that will include encryption as part of it. That will include that compression as that data is being encrypted as well. So, just by putting a WAN accelerator on there and hoping that you can compress that data even more and send it across, well, unfortunately, you're really not adding a ton of benefits from there. So, that's why we took a look at that problem set from a technology perspective and developed SMB Stream in order to solve that. I think, Doug, you're going to go into a little bit of detail, really showing how we address some of those problem sets, and then go into a demo as well. So kick it over to you now.
Yep, very good. So what I want to highlight is exactly what you said. This isn't, your traditional WAN accelerator. People think of WAN acceleration as doing things like caching, dedupe, compression, and to your point, SMB, for the most part, using 3.0 breaks all of that because it's already encrypting or compressing a file. And even today's modern files, they just can't be deduped or compressed. So we see a lot of video data flying over the internet. When you're talking about video data, video data is already compressed, right? Your H.264 stream or your JPEGs are compressed. And even when you look at like Word documents or PowerPoints, the old .doc was a normal file that could be compressed really well, but .x or docx or pptx or any of those ones ending in an X, the newer modern formats, they're already compressed. And so SMB Stream achieves what it does. Where did my slide go? There we go. It achieves what it does a totally different way than your current standard WAN acceleration of caching, deduping, compressing the header, all that neat stuff. What it does is right off the bat, it removes all TCP. So your filer is still going to speak TCP. It's going to speak TCP to your agent or your controller. We'll go over architecture in a minute. And those are going to be in the same network as your filer. So we're talking about sub-millisecond that you're spending in TCP, and it's going to strip it all. And where a normal VPN is not stripping any of it, in fact, it's encapsulating it. Back to your reference about those Amazon boxes where you're putting a box in a box. Well, you've got your SMB, it's talking TCP, and you're going to ship that over your VPN. If your VPN then puts that in TCP, you've just doubled your problems. Well, all the problems you brought up with TCP. Now, a lot of modern VPNs use UDP, and that's what we're going to be demoing later on to give you the best possible demo, so that's not adding any real layer or anything to the encapsulation, but you're still talking about, if you're going from London to California, 6,000 miles of TCP with all those problems you brought up on the internet. So the first thing for people to understand is we are stripping out all the TCP. The next thing is we are minimizing those pauses. So TCP, as you said, it has a window, and a window is how much data you transmit before you get an acknowledgement. So let's say that you've got a 1 megabyte window right now, and it's an adjustable window in TCP. It self-tunes. It's great. We'll be able to see this in the demo. But if you got 100 megabit internet connection, that means roughly you can encapsulate or you can send on that pipe around 13 megabytes per second. So 100 megabits divided by 8 is like 13 point something. And so that means that if you are talking again from London to California and your round trip latency is 150 milliseconds, and you take a 1 meg file and you go to send it across, or you have a 1 meg TCP window and it sends that 1 meg, it's going to take it 100 milliseconds, right? So a tenth of a second to put that on the pipe. And then it transmits to your destination, and the one way to that destination is say half of that, 75 milliseconds, and then the destination has to acknowledge that the window was received and everything's fine before you send data again. So if your round trip time is 150 milliseconds, but you have a 100 megabit internet connection and you have a 1 megabyte window size right now, then what we're talking about is you're transmitting for 100 milliseconds and you're waiting for 150. That's over a 50% just idle time where you're just sitting and you're waiting. And that's assuming that you don't drop any packets, that no packets come out of order, that you don't violate any of those stateful things in TCP, because otherwise you're going to need to retransmit. And so another thing we do is we handle the retransmission. So we've got a window as well. We send all the data, and we send that data, and we keep sending the data. We don't stop sending the data. If we find that we dropped or missed a packet or it's out of order, we correct that on the other side without stopping that data stream. And so even when you have high latency or packet loss, you're going to see that overall SMB stream just works. It's just going to send your data, it's going to accelerate, it's going to move it. And again, we have advanced out of order handling. So we're really looking to address those issues that you brought up with TCP. The SMB stream is also compatible with the Enterprise File Fabric. So the Enterprise File Fabric is a tool that many companies use that gives you the ability to look at your filer remotely. This isn't a full presentation on the Enterprise File Fabric, but we'll go over it a little bit towards the end. And so we have desktop clients. We convert things like SMB to HTTP or HTTPS, and we send that securely, and that can be on your mobile device. It can be via a web browser. It gives remote workers the ability to use this data. So SMB Stream can take a filer and make it available to a remote location. That remote location could have a enterprise file fabric, and that enterprise file fabric can make it available to Macs, Linux, Windows, Android, iOS devices everywhere. And the enterprise file fabric has this feature called MStream. We'll be demoing this later as well. And what MStream does, it's a further layer of enhancement. So we're no longer limited by the SMB protocol. We're taking the SMB protocol completely away. And so these two technologies, SMB Stream and MStream, are going to work in parallel. They're going to work together. And so this is going to replace the complexity you have with setting up multi-channel. This is going to give you parallel file movement. So, I mean, how many times have you had a folder and had a whole ton of small files in it, and you clicked and dragged it in Windows Explorer? Even if you're in the office, you're on a 1 gigabit connection, and it took forever because it sends one file at a time, one, open, close, open, close, open, close. And so you might have only moved 10 megabytes of data across a gigabit link, and yet it still took 5 minutes, and you're going, but I have all the throughput. So this is something that MStream takes advantage of. As well as we've baked into the Enterprise File Fabric some enhancements specific to SMB Stream, when the two of them talk together. So one thing that's always important is permissions. If you're using a filer, you want to make sure that when you click on that filer, that you only see the files that you're supposed to see. And we can actually, SMB Stream accelerates that as well. And you'll see later, 5 to 10x. But we've actually done some more enhancements along the lines of the Enterprise File Fabric, where you can speak an API to translate those permissions, and you get more like a 50 to 100x improvement in things like ACL transfers. So that's not your file, that's the listings, the directory listing, the permissions and whatnot, as well as the Enterprise File Fabric is able to use SMB Stream to bring AD or LDAP to a remote location. So you're in a remote location, you want to use SMB Stream to get access to your filer, but maybe you also need access to your AD system. And maybe your Windows desktop needs to join the domain. And so SMB Stream is able to do that and accelerate that as well. SMB Stream, it's paramount to us to have security, to have the top level security. When people think of VPNs today, obviously there's Cisco and there's Juniper and there's all the, SonicWall. There are all these great VPNs, and the whole thing about the VPN is it's got to secure your data. It's got to be the best in breed. And so we think SMB Stream security takes that up a notch. So you can go out, you can check to see if your Cisco firewall is currently encrypting data in transit with TLS version 1.3. 1.3 is the newest, it's the greatest, it's the strongest out there. It should be replacing 1.2 in a few years. SMB Stream only uses TLS 1.3 for data in transmit. There's also the authentication. So you want to verify that the agent and the controller, they know who they're talking to. You don't want a man-in-the-middle attack. You don't want somebody impersonating you. And so we do authentication very stringently, and it's very similar to the way you do it on a VPN. Anybody that's had a VPN, often your administrator says, I set you up an account and you're going to need this file, which is a key. It's got keys in it, and you're going to need a password in order to get in. And so we essentially do the same thing. So when the agent speaks to the controller is first going to sign something using a key of RSA 4096, so 4-byte key, saying, I am the controller, and that allows the agent to then trust the controller. Of course, the controller also has to trust the agent, so the agent has its own signing that it will do along with signing a password to ensure that the two of them know that they can have this secure TLS 1.3 exchange. That doesn't mean that now you've got free access to SMB. Once that happens, the controller is going to make available that SMB share locally. And when a user connects that share, they still have to do just like they would in the office. If you're in the office and you click Map Network Drive, it might just connect because it's got your password and everything, or it may say, who are you? Please input your username password, and that's your NTLM, or that's your Kerberos security. So we don't strip any of that out. We still leave all the SMB authentication. If you're running SMB with encryption, then great, it's double encrypted. You've sent it encrypted data over the TLS 1.3. You could remove encryption for those endpoints if you wanted to, knowing that we're going to do it. But if you want to double encrypt it, that's really not a big deal. Sure, it's going to slow you down a little bit more, but you're already taking that hit on your VPN as well. And then the last thing is the only configuration, we'll talk about ease of setup and everything, but the only configuration you really have to do is going to be on the controller. You're going to make a public port available, and you're going to be able to define that public port. And so by default, we set it to 8445, but you can change it to a different port number. And why that matters is you see a lot of things today coming out only on 443. They're only on 443, they're only on 80, they're only on 22. And this is the security through obscurity. There are so many script kiddies out there. If today you go into one of your Amazon VMs and you're in your Amazon VM and you log in, it might say there were 1,000 attempted logins by root, during this time, and that's because you've got port 22 exposed, and they're just hitting that port, hitting it. But if you expose a different port, it's not that you're invulnerable now, but it means that the drive-bys, they're not going to be scanning 65,000, ports that are available in UDP or TCP. They're probably going to say, oh, okay, there's nothing open here. So it gives a little bit of extra ease in configuration and security. So the architecture of this. Oh, go ahead. Yeah.
Yeah, no, I just wanted to bring up, so just a quick question had popped up. So the person said, I like all the security capabilities, but this sounds like it may be fairly complicated to set up with key exchanges, passwords, etc. Thought you mentioned one of the downsides of VPN was complexity to set up. Don't we just have this now with SMB Stream? So I know you're going to demonstrate that as part of the demo later, that setup, but I think you mentioned as well, a lot of configuration just done on the controller side, and then apply that configuration to the agent. So
yeah,
touch on that.
We'll demo that. It's going to be it's going to be simpler than they think. And so we've got images for VMware. It can be part of your enterprise file fabric. We have Hyper-V, we have KVM, we have AWS AMI. You literally just deploy the image on your hypervisor, whether it's the controller or the agent. So as you see here, I've got a controller in the middle. A controller can talk to multiple agents. You simply need to give it a FQDN and map that one port number. You're not doing what you do with a VPN if you're a network administrator of creating, a number of different users. You're not doing what you do as the network administrator of creating routing in different tunnels like that. You deploy these two things, you'll be up and running in 5 minutes. It's much simpler in that the controller, if I've got this controller here and I've got a Azure region in India and I've got Azure files set up, this controller is just going to act like it is this Azure files. And so a server, a client, a EFF client is just going to connect to the controller at its IP address /share name, as if everything's local. So you will get to see it, but it is simpler to set up. But the architecture is pretty simple. You have one controller. You can have many agents. Those agents can be all around the world. An agent can speak to many different filers. So if you got 10 NetApps in your Tokyo remote office, that's fine. Isilons doesn't matter. It is compatible with, really any SMB filer, and that's from version 1 to version 3.11. I don't recommend, obviously, for security reasons, that you do version 1 anymore, but very simple to set up, and this is the basic architecture. The use case that we're going to talk about is really anytime you've got a remote filer that you want access to. So that could be that you have remote offices. So maybe you have offices, you have your headquarters in London, and you have an office in California, you've got an office in Australia, and you want the people in the main office to be able to work on those or with those remote filers. It can go the opposite way. So it could be that you keep all of your data in the central office in London, and you want those remote offices to have access to all of your data. We've seen a lot of people moving to the cloud, and so this can be one of two directions. Some of the organizations we work with, they take advantage of the compute in the cloud. So they want to keep all their data on premise, and they just want to do compute. Maybe that's AI or machine learning or some sort of log search. And so they want to make their data available to the cloud because it's got cheap compute that they can stand up and get rid of. And so they want to bring their filer up to Amazon, to Azure, to Google. You're going to be able to do that. Conversely, we've also seen smaller offices, or even actually some big ones, say, you know what, I'm tired of having a filer on-prem. I still want all my people on-prem, but I want to use FSX, or I want to use Azure Files or something up in the cloud as my filer. I don't want to pay that electric. I don't want to be changing hard disk, but I want to make it available in my corporate office. SMB Stream can do that as well. And then, of course, again, talking about the enterprise file fabric, it brings NASs to a remote enterprise file fabric. So we have people deploying enterprise file fabric in clouds, but their NAS is on-prem, no VPN required. Likewise, you could have one of our hosted, where we take care of the enterprise file fabric from you, and you don't have to do any of the setup or complexity.
Yeah, and that cloud's on-prem. We see that a lot. We see a lot of customers really trying to move both cloud first, cloud native. But as you start to think about it, it's okay. Well, what about file servers? How do we make file servers cloud native or cloud first when our users need to access that data, right? VPNs often is what's put in place there with all that issue we see above, or things like virtual desktops in the cloud, which does have its fit for some use cases. But if you're just taking standard office workers and giving them a virtual desktop just because you move your file system to the cloud, it's a bit of a sledgehammer to solve the problem.
Well, and I think it's also a cost factor, and obviously everybody's budget's differently, but what I see is that most of the clouds are giving away the storage almost at cost. I mean, don't get me wrong, you could build your own free NAS for cheaper than the price of Amazon S3, but the storage in the clouds is very inexpensive, and there's a reason for that. There's this concept of data gravity, and so a lot of the offices we work with today say, I want to take advantage of that, but running all these virtual desktops in the cloud, well, that's where they're killing me. They're not as fast as my actual Mac. People can't, they're not portable, they're not this, they're not that. If my internet line goes down, everything's down. They've got all these different reasons. So why not take advantage of literally what the clouds are giving away almost at cost? So there are a ton of benefits, and I don't want to spend too much time. I want to get into the demo, but again, this is going to be easier to set up. It's going to be faster than a VPN. It's going to show speed improvements with further latency. It's transparent to the end users, and the main thing is it works with kind of any NAS filer out there.
Yeah, and that's key, that transparency to the end user. So one of the questions that just popped up was what software needs to be installed for this to work? And I imagine the question is more so from the end user perspective, not the server side. And so from the end user perspective, there's nothing, right? They're talking SMB to the controller. So nothing needs to get installed locally on the user's machine. They're going to continue to make a SMB connection to that local controller, which it will then talk over that UDP to the agent and directly to that NAS. And we'll show that as well in the demo.
Absolutely, right? So it doesn't matter if you're Mac, Windows, Linux, like if you're Windows, you just click Map Network Drive, and the only thing that changes is that instead of giving the IP address of the filer over the VPN in the remote location, you give the IP address of the controller sitting in your local office. That's it. Let's talk about performance here. So we have a data center in California. We spun up some AWS nodes, around the world. One of them we spun up in California, so you can see it was only 2.5 milliseconds of latency away, whereas the other ones were further. So one thing that I want to highlight is we still improved speed. You may say, well, we have a New York office and we have data in US East 1 for Amazon. Is this really going to speed us up? We don't really have that much latency. We only have 10 milliseconds of latency. Going back to dropping packets on the internet and how SMB works as a protocol, the answer is yes. On the download, we didn't see that much difference, but on the upload, we saw almost a 5 times improvement. So, you're talking about accessing your FSX or whatever you've spun up in Amazon. It could be a NetApp ONTAP, at half a gigabit over a 1 gigabit line versus 126 megabytes a second. And so when you look at it, this is the difference between having 5 workers opening big files at the same time, or having one worker open a big file, when they're working on this. You can see it can get even bigger when we start looking at like Frankfurt. This is California to Germany, almost a 10 times improvement. And again, this is going to be barely usable. If you got 9, these are again megabits. If you got 9, 10 megabit versus 100 megabit connectivity to your German office, it's a big deal. Same thing here. It's about 3 times improvement on downloads. Again, it just makes it usable. Same thing with London. Same thing with across the board. And so you can see different latencies. Now, why these numbers are different? Well, these are just the conditions on the public internet. And this is what we're going to see in the demo in a minute. In the demo, I can't control what the internet's doing right now. I can't control our Fremont, office location or AWS. And so I know what to expect, but I don't know what we're actually going to see. These are the same things, so the same performance metrics that you see here, but as a percentage graph. So you can see, uploads in California, even though that was, only 2.5 milliseconds away, we're still 3 times faster, a little bit faster on the downloads, going all the way to Germany, big speed improvements, London, Sydney, big speed improvements. And again, this is the difference between having, office workers say this is unusable and something that actually is usable. It feels almost like you're in the office. Obviously, you're in the office, you probably have 1 gig, links to all of your desktops and possibly a 10 gigabit backbone. And then this is the same performance numbers, just completely laid out in a different fashion. So we're about half of our way in, and I would like to skip to the demo. And so what I'm going to be showing you guys in the demo is how to configure this. We will be using our Fremont, California remote office location, where we actually have 3 filers set up. We're probably going to use our NetApp today. And it will be going against an AWS London location. I will be showing the difference between VPN, and again, I'll even show you this is a UDP VPN versus SMB Stream. And then finally, we'll do SMB Stream with the enterprise file fabric.
Yeah, and Doug, as you switch over, so I do want to apologize to the person that asked the question. The webinar chopped off unless I highlighted it to show me the full question. So I apologize that I misread the question. So the question was actually more from the server side, and they brought up that some NAS appliances don't allow third-party software to be installed. So as Doug will show and talk about in a second, the agent side also is a virtual appliance that will get installed within your data center. Nothing needs to get installed on the storage devices themselves. It will just be deployed right alongside those storage devices within your local data center or in the cloud as a virtual machine that will communicate just over standard SMB to the backend storage. And that supports any backend storage, we've done a lot of work with our strategic partner Nasuni as well, and have validated this, and it works great with them. I know particularly they often don't allow third-party software to be installed on their appliance, but we don't need anything, right? It'll just be deployed as a virtual appliance.
Correct. So these are all virtual appliances. I'm saying, let's see, download. is it download or downloads.storage-made-easy.com? But we, these are all VM. So I guess it's download.
I think it's on auto build, right?
Yep. But if we go into VMware, here's your OVA, and it's 100 and let's see, 1, 2, 3.
Top one, Doug.
Oh, 1.9 gigs. Oh, sorry, top ones. They're both 1.4 gigabytes. And to be honest, like 99% of that is just the Debian OS and what they install. I mean, the SMB stream is extremely small. So you've got OVAs, you've got KVM, QCal files. If you go into the AWS marketplace or the marketplaces, you'll be able to find this. So, no, I don't want you necessarily installing something on your filer that's going to break the warranty or anything like that. This is going to sit alongside of it. And like I said, it's not a big deal that when the filer talks to the agent, it is talking TCP because that's how SMB goes. We're probably talking sub-millisecond latency. It's all running in your data center, and you're probably got a 10 gigabit pipe. If everything's virtualized, like our Nasuni partner, then it's just within the hypervisor, so it might even go faster than 10 gigabit. All right, so let me set the stage. So like I said, I am running in Amazon, and we also have a Fremont, California location. So you can see that I'm in London. We can look at some of these in a minute, but this is my file fabric. This is my SMB stream, or I got them reversed. This is my Windows box. My file fabric is also running the SMB Stream Controller. It can be deployed on that. Here is that Windows machine that we see right here. And so this is in London. I'm in Texas, but we will be talking to Fremont, California. You can see that I have a VPN connection to our Fremont office, and we can look later and see that this is UDP and that I'm not trying to make it slow with TCP or something like that. I also have right here the Windows Task Manager up so that we can see the Ethernet speed and connection for sending and receiving data. I have 3 drives mounted, and so I've got the first one. This is my VPN. This is my SMB stream, and so you see the only difference between the two, if I look at them, they're going to look the same. So that looks the same as that. Can't tell the difference. The only difference is the IP address. They have the exact same share name, CIFS and CIFS. In here, I have a demo folder, and I have SMB Stream and VPN. The reason I did this was so somebody wouldn't say, and they've got the exact same file in both of them, that, well, I pulled this file first via VPN, and then I pulled it with SMB Stream, and it was cached on like one side in the filer, and it went faster because of that. Honestly, you're going to see that the filer is way faster than the public internet. So now let's pull this file down to our desktop. So I've got this video clip, and it's about half a gig, a little bit bigger than half a gig. And I want to pull it from the VPN to my local desktop and put it in this folder. And so I'm just saying click and drag it, say okay. And so now what we should see is we should start seeing traffic on the VPN. Okay, great. So we're seeing traffic. Now, one thing to note is that the VPN, this gauge right here, this is in megabytes per second, whereas when we're looking over here, Windows is measuring things in megabits. So, take this number, multiply it times 8, and this is what you should see over here. We have to give Windows a second. There we go, to start upgrading our graph. Now, again, I don't know how the internet's behaving right now. I don't know how our Fremont location is behaving. What I've seen before is that, we'll probably get up to 30 megabit on this, but what we should see is some sawtoothing. And so what sawtoothing is we've got our TCP window, and our TCP window has been getting bigger and bigger and bigger, which is great. But eventually we're going to drop a packet, and it's going to have to there we go. We dropped a packet, it had to retransmit, and so now we got a big loss. We got we went from 32 megabit down to 15, and they call this sawtoothing because this is what you normally see in TCP transfers. So while this transfer is going, it looks like it's going to take another 3 minutes. Why don't I just jump over here and show you how easy it is to set up the controller. So you log into the SMB controller. Again, you deploy this via an OVA, a marketplace image. You get a license file from your SME sales rep, and so you apply the license file. You click on the controller and you tell it what port number you wanted So remember I said the port number was definable. You also give it a FQDN. The reason you give it a FQDN or a public IP is so that the agent knows who to call. Then you're going to define one or more agents. So I only have the Fremont, California office here, but I could have Paris, I could have Sydney, I could have all sorts of ones. Once you define an agent, you click the agent and you're going to tell it what filers it has access to or what AD resources it has access to. That's it. You just, fill in, a few blanks. Here's the IP, here's the port number, here's how I want it exposed. You can use standard or non-standard ports for the SMB. And so that's pretty much it. Then you come here to the agent, and there is this little download button here. When you click that, it's going to give you the agent configuration file. And so again, you would go to your other office, you would spin up an agent, and you give it this one file. Now, if you make changes here, you don't have to re-download this file. This file is just the security information. It's the keys and whatnot. Every time an agent connects to a controller, the controller says, hey, I know who you are after the key exchange. And it says, I believe you should have these 5 devices, or 6, or 10. And it will just set them all up. So it's not like if you go in here and you make a change, you're going to have to reapply that file. You make the change, and you say restart the agent, or you press the restart button, and away you go. All right. So and there's really not much else. You can change the you can create administrator accounts or other accounts. Right now, I just have the default account, which I should change from the default passwords and everything like that. So let's go back to our file transfer. So we can see that we've had more sawtoothing. We can see that sometimes we might have dropped a packet, then dropped a packet, and that transmit again, and we went all the way down to nothing. Overall, we've hit around 32 megabytes per second. You can even see the sawtoothing here. However, I would guess, and this is just a guess, I would guess that if I took an average, that we're probably somewhere in the 20 megabyte or megabit for this VPN transfer. And it went sawtooth again. While we're waiting on it to finish, let's go look and see preferences, just in case anybody doubted that we're using UDP. So we are using UDP. If I had switched this to TCP, now we're double encapsulating with TCP, and my performance would probably be half this. But essentially, my VPN is taking SMB traffic, which is already TCP, wrapping it in UDP. But again, if we lose a packet, that TCP has all the retransmits. All right, if this doesn't end soon, I'm going to end it because it's kind of boring. This is what your end users experience, right, Eric? Your end users are sitting around waiting for a file to transfer. And so, hey,
absolutely.
Yeah, 6,000 miles, but it was only half a gig, and we've got gigabit connection on both ends. All right, so let's do the same thing, but let's this time copy it to this directory, SMB Stream, so that we don't get accused of caching or anything like that. And again, let's go back to my PC, and now we're going to use the SMB Stream controller. So when we do this, we don't expect to see traffic over the VPN. If we see traffic over the VPN, then it's not taking the right route. So again, I got the exact same structure and everything. Go into my demo folder. If you guys really want, I can grab the same VPN file and copy that over, but some people might say, oh, well, that one's already hot on the filer. So let's go grab one from this folder here called SMB Stream. All right, so this is going to be hopefully a much cleaner experience. I click and drag it over, and we're going to just wait and watch. Okay, so we're already at 1/4 gigabit. So we're already 10 times faster now than the transfer that we saw. We got to give it a second for Windows to catch up here, but you can see there's nothing going over the VPN. All of your data, we're still waiting for Windows to catch up. Here we go in our graphs. We spiked at maybe half a gigabit, and I mean, I was able to demo to you guys the entire configuration of the SMB Stream Controller and explain how the agent worked in more time than it took to download that exact same 657 megabyte file. And so, I hope that speaks volumes about how this works and how quick it is. And again, same link, same everything. The only thing we did was we omitted the VPN. the last thing that I would like to demo for everybody is when we use this with the enterprise file fabric. So here's the enterprise file fabric. The enterprise file fabric is currently using the SMB Stream connection. So it's connected to a number of different devices that I have in the California office. Again, these are all over SMB Stream, as well as the AD. One more thing I just want to show you guys in case anybody had doubts. We can go into the Amazon, the Windows, the monitoring, and we can see that, and sometimes these take a while. Let's see, so we pulled that data from California so we brought it in. So if I enlarge this, they don't really give you great averages. Let's change this to a second. Let's say for the last 15 minutes, all right. Well, you can see that we had traffic on the Windows machine. It's not really good enough to show, from here to here was your, it's just traffic going up. But you can see that this really is the VM that we're using in, or the instance in AWS in London. And this isn't a very big or expensive Windows instance either, right? We're talking about T3 extra large. All right, so the last thing I want to do is on this Windows machine, we have something called Cloud Drive installed. And Cloud Drive is how the enterprise file fabric can create a file share. Again, this is not SMB. This is talking HTTPS. So we're talking between these two VMs. And this VM here is the enterprise file fabric. And again, it has the SMB stream connected to it to send the data back to California or vice versa. All right, so we can do the same test, but the problem with this test, and what I'm going to do is I'm just going to, let's see, I'm going to go jump on here. We want to use the same NetApp. Let's create, I already have a folder called Enterprise File Fabric. I already have that file in there. Let's find a different file to upload, which is good, because honestly, it goes so fast that if you blink, you almost miss it. And so we want to make sure that data doesn't go over the VPN. We'll still see data transferred here, but this is going to be data being transferred via MStream, and then that MStream being translated to SMB Stream. And so this is going to go even faster because MStream and SMB Stream work great together, and MStream is able to do things like that multi-channel, is able to do parallel feeds and whatnot. So I've got a 4 GB file. I'm going to click and drag it over. Okay. Ignore this. This is it moving into cache. Watch down here. And so we should see that file getting transmitted. There we go. 500, 1.7 gigabit, 1.5 gigabit. So again, this file is what? I'm terrible with math some days. 7 times bigger. So let's see, 7 times 6 is 42. So about 7, a little under 7 times bigger than what we've transmitted so far. And what do we see when Windows is finished updating this? This is your MStream transfer. So we used MStream to send this to the file fabric. File fabric then translated this to SMB Stream, and it's ending up in the same location. The file fabric is buffering it because the MStream was able to go faster than what we saw the SMB Stream do. But the point is, how great is this for your end users, right? If you're combining the enterprise file fabric with SMB Stream, or if you're just using it natively. And so with that, I think I've concluded what I want to show everybody in the demo. And so why don't we hit questions? Where's my slide deck?
Yeah, thanks, Doug. Yeah, so if there are any additional questions, right, you can put that right in the questions box, just as some of you have been doing already. We do have one question here. Since you just showed it at the end with working with the enterprise file fabric, the question is, how does somebody that's an existing enterprise file fabric customer leverage and get MStream? So I'll say just reach out to your sales team. They're happy to work with you to be able to determine how you get that deployed in your system as well. All right, so the next question is, so you mentioned Nasuni Appliances earlier. Yep, a strategic partner of ours, Nasuni. They have an amazing global file locking technology that passes locks across the platform. How does SME handle such file locking mechanisms?
So you want to handle that one, or do you want me to handle it?
Yeah, either way.
No,
So
no go ahead.
from the MStream, sorry, the SMB Stream side, we just act like another SMB client connecting to that filer. So when a user goes to open a file and issue a lock through the controller, the SMB Stream Controller, that will pass back to the agent that SMB lock, and it'll lock against that local Nasuni filer, which then with their global file locking would then propagate that lock across all the other filers within there as well. Not to veer too far off field, but we talked about the enterprise file fabric as well, and things like that MStream technology for that accelerated downloading. The enterprise file fabric, either with or without SMB Stream, also supports the global file locking, where things that would be locked through the file fabric would be picked up by that global file locking system and locked across the filers as well.
Yep, I see another new question that came in. It says, how is this different from Microsoft SMB over Quick? And so it's very different. The first one is, I mean, I'm sure there's some co-overlapping technology involved, but when you think about it, that's a Microsoft-only product, so it's only going to work with full Windows Server. So if you've got a Nasuni or a NetApp or a Panzora or a FreeNAS or whatever you have, it's not going to work. You're locked into Microsoft. The second thing is, I don't even know that that's really released. I looked at it. It was part of the 2022 preview, and then when 2022 server came out, it was not included with it. I don't know if it's going to come in a later service pack or if it's actually out. I haven't kept up to date with it. And I think the reason it didn't come out is I saw some people complaining online that it basically just exposed your SMB publicly on the internet, which they always tell you don't do. And it's secured with Quick and TLS 1.3. But that's the transfer. The transfer is secured. The authentication was limited to only NTLM version 1, which means essentially you've got your SMB sitting out on the internet for people just to bang on all day long, trying to guess your username, password, and whatnot. Again, we have a step before that. You can't just, go bang on our controller and say, I want to see this SMB share and guess passwords. You've got to do that entire authentication that we talked about before, and that's only for an agent, before you get connected to then do the Kerberos or the NTLM authentication. So like I said, I haven't kept up to date with it, but if you need something, you don't have a Microsoft filer, then this is really what you want to do. And again, I think it's only available maybe right now for Azure. Anything else come in while I was talking about that one?
Yeah. So one of the questions was, and I think maybe if you want to jump over to the demo, we can show as well. So the question was, can SMB Stream be used to map a drive on Windows, potentially between a desktop client and the Nasuni filer? So I think you touched on it, but if you can just provide the additional color, those drive mappings, what they're actually talking to, I think that may clear up that question as well.
Any filer. So why don't I just disconnect this one? Let's do disconnect. But it doesn't matter what the filer is, and I probably need to remember this IP address, 31.10.183. Come on, Microsoft. Sometimes, okay, it did disconnect. It just didn't update my screen. Oh, because I was sitting in it. All right, so let's close Explorer, reopen it. It's still showing it mapped. Let's close all of them. This is a Microsoft problem, not a SMB Stream problem. But when it decides to unmap it, there we go. Whether this is a Nasuni filer or not, all you're going to do, and I forget where the map button is, sometimes I cheat and I do // you put in the IP address, and this is going to be the IP address of your SMB Stream Controller. Your SMB Stream Controller has an agent, is connected to multiple agents. And so I have something like the Nasuni right here. So this is the IP address of the Nasuni in headquarters. And I'm making this publicly available on the controller with this port number. Now in Windows, I can't change the port number. They don't allow me to do :9448. Linux would. In that case, what you do is you set the controller endpoint to a different IP so that you do multiple 445 mappings, which is the default port nowadays for SMB. I know that there's technically SMB on port 139, which you could also do, but I'm also under the impression that's more the NetBIOS, that's the old stuff, that's the SMB or CIFS version 1 that you probably don't want to touch. But as you can see, I've got multiple shares available to me, as well as here is that Nasuni filer on the maybe I didn't bring in my files on it, but here's the Nasuni filer on the enterprise file fabric. I must not have mapped to a directory that had files in it. In the enterprise file fabric, you can actually pick your directory or path.
But yeah. So to succinctly answer the question, from a end user perspective, they would go to map a drive, and that would be the DNS name or the IP address of the controller that is local to them. Behind the scenes, that controller would have a connection to an agent. That agent is deployed, let's call it in Microsoft Azure, for example. That agent is a virtual machine there, which then your Nasuni filer would exist within that Azure environment that the agent talks to. So the end users, right, they're just connecting to the controller. They may not even know it's a controller, right? It may just be files.storagemadeeasy.com that they're connecting to in their local environment. That talks to that local controller and just mounts it just as if they were connecting directly to the Nasuni in the same data center or across the VPN.
Yeah, and as I brought up before, when you hit Map Network Drive, so this is the one that I mapped previously. So I already have my credentials in here. If I don't say, connect to other credentials, I was just trying SMB drive, this is the Windows security. So again, we don't strip out any of your current security. We're not giving your users full access into this. It's essentially, we're just bringing that NAS from 3,000, 5,000, 9,000 miles away to act as if it's local, and to give them the speed and performance to feel like it's local, where it's really going to be comparable to being in that office. I don't actually know these are somebody else's shares, so I don't know the password to them to map it. Sorry.
No, that's okay. Yeah, so thanks for your time today, Doug. It's very informative and probably very eye-opening to some of the people on the line watching. That, what was that, 2 minutes or something to download that same file over VPN, feeling the pain probably of their end users as they're trying to operate in this way, and then SMB Stream coming in and showing a much quicker transfer rate associated with that. So I think Marietta, I don't know if there's anything else you want to close out with. Obviously there's a handout in the webinar associated with SMB Stream. Also, if you go to storagemadeeasy.com, that has additional details on how to contact us.
Exactly.
This just shows the condition of the internet, right? Like, we got sawtoothing. We expected that because we were dropping packets every once in a while. We couldn't control it when we were doing the VPN. Speed was up, speed was down. Obviously, SMB Stream took advantage of that. But when I ran these tests before, and I can tell you, this is the same London location, AWS, same Fremont location, we got a 6 times benefit. And today we just saw on the webinar 10 times benefit. And so what is that? Well, maybe AWS in London right now is a little bit less busy than it was when I ran this test. So we've certainly seen 5 to 20x performance. And so sometimes people ask, why with 147 milliseconds of latency did Sydney get so much better of a response than London? Well, who knows what transatlantic cable was up or down that day? Who was downloading Netflix from, from Sydney, Australia? We don't control the public internet, but what SMB Stream does is it makes it, very reliable. It makes it very uniform in how it's going to have your users experience it. So again, thanks to everybody for being on the call. And Mariota, is there anything you want to do to wrap up? Oh, there's one last question.
Yeah, exactly. There's one last question here. I'm just going to read it to you. You always need a virtual machine as controller and one or more agents, right? There is no way to install directly a piece of SW or your desktop laptop?
So I wouldn't advise running this on a. So I guess I could look at the question one of two ways. I guess the first question might be somebody that wants to take this and take it home on their desktop, laptop, instead of it being an office to office. And that is a feature in a product that we're working on. That's a roadmap item, and I'm not going to talk about in this call. If you're talking about, well, in the office, we don't run VMs or servers or anything like that. I want to install this on desktop, laptop. I don't love that idea. You certainly can. It is a container. You can install Docker or something like that on your desktop, laptop, and you could run this. The only thing that I worry about there is, a desktop isn't up 24/7, and that's why you buy something like a Cisco VPN firewall, is that it's sitting there, it's up 24/7. It doesn't have the, necessarily same Windows patches and things like that. That's why you buy an ESX server that has like HA or DRS and whatnot. So could you do it? Sure. You can, on your laptop, desktop, you can install, what's it called, Vert. You can install like VMware Fusion. You can install Workplace. I forget the free one from Oracle. You can install one of those and run it as a VM. You can install Docker and run it as a container. I just don't know at this level that we're looking to support something like that. That seems like that might cause a bunch of problems versus having a reliable server-based system. And if you're looking for a desktop client for this, that's a future in the works. And so we'll have another webinar, I guess, in a few months when we're ready to release something like that.
Okay, I see that we are getting more questions, but we've just, reached the top of the hour. So if you could send those directly to SME, to the team, that would be great. You can always reach us at sales@storagemedec.com, and then, we'll be able to answer those. But we've sadly reached our time here. We need to wrap, but thank you all for attending. And again, any extra questions that you may have, just reach out to the team, and then you will be receiving an email from us with the recording and a link to leave your questions in there as well. So thank you all. Thank you, Doc. Thank you, Eric. That was great. And yeah, we hope you enjoyed it, and we'll see you soon.
Thanks, everyone.
Thanks, guys.